All right, folks. As Garth mentioned, I'm going to take you on a bit of a journey today that I've been on over the past kind of 6 to 9 months, mostly around OpenSearch and ingestion pipelines and that. So I'm going to give you a bit of context, background to the problem that was proposed within work, and a bit of description as to the solution or the integration or the route that I want to go down. Then we're going to jump into some CDK snippets because I love CDK. And then I'll give you some wrap up and thoughts and things. So who am I? My name is Peter McAree. I'm a staff software engineer at a company called Magnify. I'm also an AWS community builder, and I have been with AWS community builder for the past kind of year and a half or 18 months. So, a bit of background. So I was kind of like I alluded to, it was proposed. It was kind of this problem was put in front of me where within my company we're a kind of small startup, so there's only a handful of engineers, some kind of product people, and some sales people. And one of the main things that we're trying to do is we want to provide some form of an aggregated solution or an overview of like the different metrics that goes on throughout the platform. So a bit of context on Magnify. So the tagline is a post-sales automation tool. What that really means is we ingest a load of data from customers and we interface with loads of different, third-party providers such as, Salesforce and GitHub and different email providers and things like that, with the aim of reducing, churn whenever it comes to your SaaS kind of renewal, whenever the contract comes up for renewal. So that's the kind of context behind the company or the overview. The problem that was put in front of us was we have loads of events and data that's flowing throughout the system and platform. And one of the things that we wanted to do as the primary aim was to provide an insight into our customers about what's exactly going on. So, whenever we ingest the data and whenever we say send an action or send an API request to a third-party platform, we wanted to obviously track that. And to a certain extent we were, but we want to provide visibility in an appropriate manner to the end user. And then there was a secondary kind of problem that we wanted to potentially solve for or keep our options open for, which was across those events we wanted to possibly in the future be able to search across them. So that kind of led me down the nice path of OpenSearch or kind of Elasticsearch. And for those that aren't aware, OpenSearch it was originally forked from Elasticsearch whenever it was open source. And hilariously, as I was doing these slides, Elasticsearch is now back to being open source as of about last week. But at the time, whenever I was doing this at the start of the year, OpenSearch felt like a good fit because AWS had a nice managed service for it, and plus OpenSearch was being kept up to date in terms of being open source, which was a nice fit. So that was kind of the route that was wanted to go down. So it kind of shows in the database, and I'd used some of these products before, database before, in terms of Elastic and OpenSearch, but it was always the consumer of it. I was never really pushing data in or ingesting. My kind of background isn't a data engineer or building kind of data ETL pipelines and things, so this was all new to me. Being a startup, everyone wears different hats, and this was just one that I had to wear, unfortunately. So there was kind of three main challenges that I was kind of coming up against. So existing kind of ETL and data pipelines and things that I have never really used before, things like Kinesis data streams and spinning up your own Kafka and stuff like that. I wasn't really too fussed on doing stuff like that because this initially is obviously being in a startup, wanted to be a bit more of a prototype or a POC. Wanted to keep it quite lightweight and not get too down the dells in terms of lower level infrastructure and networking and things like that. Plus, which I'll touch on, the use cases for us, we didn't need it to be anywhere near real time or anything like that, especially given it was a prototype and stuff too. The second one then was it's quite costly. Being a startup, we want to keep costs, as everyone should. There's always room for optimization, but we want to keep it quite lean from a cost perspective. So this kind of meant that I needed to be a bit creative or look outside of the box in terms of cost. Plus, the third one then is we're quite heavily using cloud native kind of technologies and serverless. We do a bunch of like orchestration through Lambda, Dynamo, step functions, and all those sorts of things. So that's what kind of my engineering team is used to, and I wanted to keep that interface similar enough so that I didn't have to, change or create a new service to just handle these things. So that's whenever I did a bit of research. Given all of that sort of context, the solution that I nicely came across and landed on was a direct integration between DynamoDB and OpenSearch. through their ingestion pipelines. So this was something that was announced at reInvent last year in terms of like a first class of native integration between Dynamo and ingestion pipelines. So this was kind of, music to my ears. My engineers are used to pushing into DynamoDB, and if I can ingest straight from that, happy days. I don't have to do any, real legwork in terms of spinning anything hard up, if you know what I mean. So from an architectural perspective, this is kind of what it was aiming for. Like I said, prototype POC, so everything was kind of subject to change potentially, but this was what kind of the flow that it was going for. So we'll have our kind of producers being our Lambda functions, pushing into DynamoDB as normal, and then within OpenSearch and their ingestion pipelines, we can then take basically consume from our Dynamo table and push it directly into an OpenSearch index. So that would give us the lovely functionality of OpenSearch. So then I wanted to I love CDK, and being a community builder, I read a lot of CDK and different blogs and things like that. So I really wanted to define this kind of solution using CDK. So I'll walk you through a couple of code snippets now that are just kind of somewhat representative of what it would look like. So you can kind of see here, we're defining the Dynamo table. Nothing too special about this, but there's two key things or two key features that need to be turned on in order to kind of support this flow. The first one being point-in-time recovery needs to be enabled on your Dynamo table, which everyone has by default, of course, right? Yeah. And then your Dynamo streams need to be enabled as well. So the Dynamo stream is the critical key part here. That's what actually enables the pipeline to read from the stream, push it, and ingest it directly into OpenSearch. So those are the two key things, but nothing outside of that, nothing too special about the Dynamo table. We're also defining S3 buckets. So whenever I show you the next kind of snippet in the ingestion pipeline itself, there's an option to kind of export as well, or kind of do a bit of backup whenever we're reading off the stream and pushing into OpenSearch. So this is just an extra little bit of resiliency, I guess, whenever it comes to consuming and reading from the stream. So again, nothing too exciting, no public access and encrypted at rest. Then we kind of get on to the meat of the pipeline itself. So the IAM rule that the pipeline assumes is going to need kind of those three things that I've already mentioned. So we need to read from Dynamo, we need to push into S3, and we need to obviously push into OpenSearch itself. So this rule and policy kind of just dictates that it can push into OpenSearch using the described domain and then the OpenSearch APIs and things like that. We then have our two managed policies that we're attaching to the rule, so Dynamo access and S3 access. Of course, everyone should limit down their resources that your IAM rules can do and stuff like that, but for all intents and purposes for a demo, easy, just hit this box. And then the real meat is the pipeline definition itself. So I'll break it down into two parts. So the first part is sorry, I meant to say that's this kind of pipeline or this example is pretty much taken from, say, the OpenSearch docs themselves. There's nothing too fancy about this for now. Depending on your use case, might need to tweak some things, but this kind of got it up, gets it up and running straight out of the box. So the first thing we're defining is our source. So our source is obviously where we're consuming the data from or reading the data from. We're basically just saying that we're pointing at the table, pointing at the stream, that we always want to start the live stream shard. And then we're also exporting kind of to S3 as well, which is an optional kind of thing in terms of this whole flow. Then the second part of it is our sync. So this is where we define where we actually want to push into OpenSearch and the particular index that we're actually writing to. So you can see we're defining the kind of hosted domain, and then we're also specifying the index. The kind of key thing here are some of the additional attributes there that you might not have seen before if you're familiar with kind of OpenSearch pipelines, but the document ID, the action, the document version, the kind of like special syntax. I'm not really sure if there's a name for it, but like the special kind of syntax where it's that's kind of part of the integration, the first class native integration. So we're kind of calling a get metadata method to get the primary key and other various things that the DynamoDB integration exposes. The final kind of key part of this is our template content. So whenever you're creating an OpenSearch index, for those of you who haven't before, you kind of define your different data types and things like that that are important for performing different operations and aggregations and things like that in OpenSearch. So one of the things that you can do if you don't have an index already defined is do that and allow the pipeline to actually create the index for you on your behalf whenever it first starts ingesting. So here you can kind of see an example one where we just have an ID and a timestamp field, which maps directly to what we would have in our dynamo table, if you know what I mean. But here we're just defining that it's a keyword, basically a unique identifier, and then our timestamp is just date that's the format's epoch milliseconds. So we kind of pipe that all in and generate it, and then we're ready to kind of provision our actual pipeline. So there's no level 2 constructs in CDK for the OpenSearch ingestion pipelines. So it's kind of just an L1 construct with the cloud formation. But it's fairly straightforward, and I kind of think that an L2 construct would be the flow that we've kind of just defined there altogether, and that you could wrap up in a single construct. But for my kind of use case or prototype, I just define them all as individual methods and things. So there's a couple of things here, key things as well that we define. We define the min and max units. So these are the OpenSearch ingestion pipelines is part of the managed service within AWS OpenSearch service. And the min and max units basically it defines your thresholds for your scaling. So it's an OCU, an OpenSearch compute unit is what your billable kind of unit would be, and that you're charged, say, per hour, and things like that. So all we're specifying here is we want to have a minimum of 1 and scale to 4 if there's loads and loads of events. So that's all great, and we kind of do a diff and we deploy, and this is our output, which is lovely. And then whenever you jump into the console, you can actually see in the pipeline section, you can see our nice new shiny pipeline, which is created. So this is in OpenSearch. And then on the flip side, on DynamoDB, you can see our shiny new integrations tab, which defines the integration to that pipeline and that domain as well. So that's all great. And that works really well out of the box, and everything's running super smooth, and we're pushing documents into our new OpenSearch index. So that kind of solves for the 2 use cases, or 2 out of the 3 challenges, sorry, I should say, that I was coming against. So complexity was, I know I've rattled through that CDK, but the complexity versus something like spinning up your own Kafka instance, or looking at Kinesis data streams and things, I think the complexity is fairly low there, and also it allows kind of my engineers to continue to push the same interface they're used to being DynamoDB. So the kind of final part was the cost aspect. So it's still somewhat costly if you're constantly running those pipelines, right? Depending on your min and max units defined and how long you're running it for, it still can rack up. So one of the things then I wanted to kind of see if we could leverage was EventBridge Scheduler, which is a fantastic service that integrates with pretty much everything in AWS. And luckily, again, a kind of nice native integration into the OpenSearch ingestion pipelines. So my thought process here is essentially just creating a cron job that would spin up and spin down, depending on my use cases and things like that. And that's exactly what it did. So like I kind of mentioned earlier, my use case didn't need to be real-time ingestion, didn't need to be different things like that. So I could basically define a cadence that we were happy with and work, and then I would just start and stop the pipelines for what suited our needs. So for example, in non-production, we were just running it once per day for 1 hour, and that would ingest everything off the stream that we needed for the index, which was great. And then some CDK to find that as well. So we've got our IAM rule that our scheduler is going to assume. So it's going to be able to, again, just full access right to OpenSearch. Everyone locks it down. This is only demo purposes. And then our 2 pipelines. So there's nothing too dissimilar here between the start and stop, but you can kind of see him defining a cron expression. And then the kind of target block is defining that it wants to point to the start pipeline for the OpenSearch ingestion service. So as you can see, there's very little difference between the start and stop. But you can see that I'm just defining it. Start at 5 a.m. UTC, stop at 6 a.m. UTC, Monday to Friday. And that was great for non-production. And then we just kind of provision them, run them, deploy them, and that all works really, really well. So our producers continue to write down as normal. The events will live on the stream, and then EventBridge will then kick off the pipeline, it ingests from there, and we then have our nice new shiny documents in the index, which is great. The only thing to note, which is a somewhat limitation depending on your use case with DynamoDB, is the streams. The messages on the streams are only available for up to 24 hours. So depending on the cadence that you're defining, you need to make sure that you're consuming from that stream within a 24-hour period from being put onto it or available on the stream. And this is something that wasn't quite suitable for us in production. We wanted to make sure that we were constantly, we weren't dropping messages at all, if you know what I mean. I think Kinesis is slightly different in terms of it can support 48 or 72 hours, whatever. But again, for our use case, this was kind of totally fine and fairly lightweight still to kind of cope with. So yeah, for non-production, basically running it once per day, Monday to Friday, and then for production, we were just running it for consistently for say 6 or 7 hours for the full week. So still some costs associated with it, but at least we can get some optimization back, given that we didn't need that kind of real time feedback and stuff like that. So that was a very, very quick whirlwind of my kind of experience over the past 6 to 9 months of going from not having any experience of really doing this or ingesting directly into search, to I was able to meet our existing interface and we were able to utilize all the nice shiny features of OpenSearch, which is great. The two continued challenges, like I kind of mentioned there, first one being the DynamoDB stream limit. So having to consume within that 24-hour period is very important. If you definitely don't want to miss any messages. And then the second one then is a kind of interesting one. So depending on my use case here was I only had 1 or 2 indexes that I was concerned about initially. So I kind of just created a one-to-one-to-one mapping between Dynamo table ingestion pipeline and an index. But that I could see that getting out of hand depending on how many use cases and things you had and how many indexes. So there's definitely some optimization and tweaks there that could definitely help or streamline it a bit more. So yeah, that was hopefully you kind of learned something new or made you aware of the kind of announcement that happened at Event last year. Like I said, it was music to my ears whenever I heard, because it didn't mean I had to get into the depths of anything too funky with Kinesis or with Kafka or anything like that. And being a startup, it was perfect for our kind of use case. So yeah, thank you very much, folks, for listening. The LinkedIn's up there if you want to catch me. I'm a volunteer, so I'm going to be here all day today as well. And this talk is kind of derived from 2 blog posts that I put on my website as well. So you can kind of see all the CDK snippets if you're interested in that sort of thing as well. And they're all on there. But if you want to chat or catch up or anything after, give me a shout. Yeah, thank you very much for listening.